Welcome, everyone. We're just going to give it, if we may, 30 seconds just to let a couple of other attendees join, and then we'll get started. Okay, I think we might get going. Again, welcome everyone. Thank you for joining us for the media preview of Deep Sea Mining Watch. My name is Sarah Bladen. I'm Chief of Strategy and External Affairs with Global Fishing Watch. Before we get started with handing over to the speakers you're here to listen to, I'm just going to do a little bit of housekeeping. So just to underline that this briefing is under embargo until this Thursday, the 4th of December at 9 a.m. US Eastern Time. We will be distributing a media kit and an embargoed press release to all of you at the end of this briefing, and my colleagues on the communications team will be on standby for any follow-up questions you may have in the lead up to Thursday's official launch. If you do have questions during the briefing that's going to be provided to you by our panelists, please do leave them in the Q&A. You can click on that at the bottom of the screen. You'll see a Q&A box. You can add them there during the presentation, and then we will have a facilitated Q&A session at the end where you can also pose questions. And last but not least, I should say that this briefing is being recorded. So as way of a brief introduction, today we're going to be exploring one of the most important and least understood frontiers of ocean governance, and that's the emerging industry of deep sea mining. The International Seabed Authority, which regulates mineral-related activities in areas beyond national jurisdiction, has issued more than 30 contracts to explore deep-sea mineral deposits, and more than 1.5 million square kilometres of international seafloor, which is nearly the size of Mexico, has been set aside for mineral exploration. To date, the ISA has only issued exploration contracts, but it is developing regulations to govern the transition to exploitation. Understanding what vessels are involved, where they are, and when activities are occurring is increasingly urgent for this potential frontier of resource extraction. And this is where Deep Sea Mining Watch comes in. It's an initiative of the Benioff Ocean Science Laboratory, which is a Centre for Applied Marine Research Conservation at the University of California, Santa Barbara. And in 2016, they released a public map tracking vessels believed to be prospecting the oceans for minerals and the location of claim areas. Today, we're going to be previewing the Deep Sea Mining Watch portal that's now hosted by Global Fishing Watch and leveraging the organization's technology and data to bring greater transparency to deep sea mining exploration and potential future exploitation. Today, our panel will speak to the technology behind this new portal, the challenges of tracking deep sea mining activity in the deep ocean, and what increased transparency could mean for the future of ocean governance. So without further ado, I'm excited to introduce you to today's panel. We have Paul Woods, the co-founder and chief innovation officer at Global Fishing Watch, serving as the principal architect of Global Fishing Watch technology platform and leading the organization's technology vision. Today, Paul leads the long-term vision for using AI, remote sensing, and scalable big data technologies to help address some of our most pressing challenges in the management of our ocean. Dr. Douglas Macaulay is a professor at the University of California, Santa Barbara, and adjunct professor at the University of California, Berkeley. He's director of the University of California, Santa Barbara's Benioff Ocean Science Laboratory, and Professor Macaulay was named a Sloan Research Fellow in the Ocean Sciences and serves as a member of the World Economic Forum's Friends of Ocean Action. And last but not least, Dr. Diva Amon is a senior advisor at the Benioff Ocean Science Laboratory and a marine ecologist focused on the little-known habitats and animals of the deep ocean and how our actions are impacting them. She's published more than 90 scientific papers, including on the issue of deep sea mining. This contributed to her being awarded the inaugural International Seabed Authority Secretary General's Award for Excellence in Deep Sea Research in 2018. So I will now hand over to Dr. Amon to get us started with an introduction to Deep Sea Mining Watch. Over to you, Diva.
Thank you so much, Sarah, and good morning, good afternoon, good evening, everybody. So I'm just going to provide a little bit of background today. If we could move to the next slide to build a case for why Deep Sea Mining Watch is such an essential tool. As many of you may know, we are accelerating, the push is being accelerated to get minerals such as cobalt and nickel from the ocean. And so I want to share a little bit about what this looks like, where it might occur, and what some of the potential impacts might be, as well as what we are putting at risk by accelerating this industry forward. So it's important to recognize before I begin that there has not yet been any commercial mining that has occurred, only a handful of tests so far. So what might deep sea mining look like? Well, in the video, you should have seen that there was a collector vehicle that moved along the seafloor. Then that collects, in this scenario, polymetallic nodules from the abyssal seafloor. They are pumped up this riser pipe, you can see here, to the vessel that is waiting above. And then the nodules are separated from waste that will be pumped back into the ocean. That waste will be comprised of water of different chemistries and temperature, sediment. If we could play the video again, sediment, as well as metal fines from the nodules. And it's not yet known at what depth that wastewater will be discarded into in the ocean. And so there's going to be a lot of impact, potential impacts from this process, which I'll talk a little bit about later. So if we could move to the next slide, please. So where might mining, deep sea mining, take place in the world's oceans? We've already heard from Sarah that the International Seabed Authority, this UN-affiliated body that has been mandated with regulating all mineral-related activities in areas beyond national jurisdiction. Those are the blue areas on this map, also known as the high seas. And it's important to note that in this area, resources are what we call the common or mineral resources, I should say, are what we call the common heritage of humankind, which means that they belong to every person on the planet, every person that is yet to come also, so future generations. And so far, as Sarah has said, they issued more than 30 licenses for mineral exploration as a precursor to deep sea mining or exploitation in the future. And so we can see here on this map the main areas of interest which consider different mineral resources also. So in the red on the left of this figure, we can see this is the Clarion-Clipperton zone in the Pacific. This is where there is the most interest, especially in polymetallic nodules that sit on the abyssal sea floor. Then in the center of the Atlantic, you can see there are some contract areas there. Those have been granted for polymetallic sulfide exploration on the mid-Atlantic ridge. And then off of the southeast coast of Africa, we can see that there are also some contracts that have been leased there in green for also, again, polymetallic sulfide exploration as well. And then just off to the right of the figure, in the Western Pacific Ocean, you can just see some orange contract areas. Those are for ferromanganese cobalt-rich crust areas. And in total, these are the more than 30 areas that have been leased. But in addition to what Sarah has already mentioned, we also have the black areas of the ocean that you can see on this figure. And so those are exclusive economic zones. They are governed by the sovereign state that they belong to. And deep sea mining is also being considered in many of these exclusive economic zones, particularly those of Norway, the Cook Islands, Japan, and most recently, we have seen a really quite large step in acceleration by the US, particularly for the waters of American Samoa and the Commonwealth of the Northern Marianas Islands, as well as within federal waters around continental US itself. If we move to the next slide, so those areas that are currently under consideration for deep sea mining may not seem like a large part of the planet's sea floor, but when you think that this is what the potential resource is like on the deep sea floor globally, it means that if not done responsibly, there is a very real risk that deep sea mining could be one of the greatest threats to face the ocean. And its monitoring, as well as not just its monitoring, but we need to make sure that if this industry moves forward, it is informed by robust science and impacts can be mitigated. So next slide, please. And so what might these potential impacts actually look like? Well, scientific research is showing us that the projected intensities and methods, as well as the scales of deep seabed mining, will cause significant environmental impacts in some of the world's most pristine ecosystems. So this includes at the sea floor, as you can see on the figure on the left, the collective vehicle will actually be removing and destroying seafloor habitats as part of the mining process, along with any of the fauna that inhabit those ecosystems. Then there will be a sediment plume generated by the seafloor disturbance, which you may remember from the first video. Then there will be this secondary plume that will be released, the dewatering plume you can see in the middle of the figure, which will extend, both of these plumes will extend the scale of deep seabed mining. And that dewatering plume will potentially extend it tens to hundreds of kilometers beyond the actual mining area. In addition to this, there will be changes to water properties as well as increases in noise and light. And these deep sea mining impacts could be considered inconsequential on scales of sort of tens to hundreds of kilometers potentially. But the scales that we are talking about, as you would have seen from those global maps I showed earlier, are enormous. In the Clarion-Clipperton Zone alone in the Eastern Pacific, some industry projections are to directly mine about 500,000 square kilometers of seafloor. And when you combine that with the plume impacts, that stands to increase the area of impact by at least 3 times, so to 1.5 million kilometers squared, yielding a footprint about the size of these US states that you can see here: Arizona, New Mexico, Utah, Nevada, and California. But then, of course, the ocean is three-dimensional. And as you've heard, there will be this secondary or dewatering plume. And so that stands to potentially extend these impacts through the water column from sea surface to sea floor. And there were some projections made that show that this could disrupt, just in the Clarion-Clipperton Zone, 6 million cubic kilometers of ocean. And so mitigating these impacts is really critical for this industry to move forward, essentially, if it's to avoid serious harm to these ecosystems. But that is really compounded by a lack of science, critical science that is needed, and a lack of regulations. And in fact, there is so little science that a study that I led with others found that just 1% of scientific categories assessed across regions with deep sea mining licenses in areas beyond national jurisdiction had enough scientific knowledge to enable evidence-based management. So really, there are a lot of more questions than answers still. Next slide, please. And finally, what are we putting at risk by accelerating this industry forward? Well, we have a much better understanding as a result of a lot of the science from the last few decades of how important the deep sea is. It's enormous, and that enormous size means that it provides big global ecosystem functions and services that we all rely on, that keep the planet healthy and keep essentially all of us alive. So yes, it feels out of sight. Yes, it feels out of mind and out of reach, but every single day we depend on the deep sea in some way. And so, for instance, some well-known ecosystem services are support for fisheries that billions of people around the world rely on. We know that it's a likely source of marine genetic resources in the future that could be useful in medicine, biotechnology, especially given the unique conditions that many of the animals down there have evolved under. We know that it regulates our climate, it absorbs heat, and it sequesters carbon, locking it away for thousands to millions of years. And there are, of course, cultural services as well. So there's a lot to consider around how this industry moves forward. And so I'm going to hand over to my colleague, Professor Douglas Macaulay, to talk through why Deep Sea Mining Watch is an essential tool.
Thank you, Diva. Thank you all for being here. Next slide, please. So I'm excited to just sort of get into the meat of the matter here about the launch and unveiling of Deep Sea Mining Watch, which has been a long time collaboration in building this project, and now I can't tell you how excited we are to share it. A collaboration in this construction between our research team here at UC Santa Barbara and the Benioff Ocean Science Laboratory, and our collaborators at Global Fishing Watch. So my colleague at Global Fishing Watch, Paul, will share in a minute a little bit more of a deep technical dive of what you can see and how we make that visibility possible. But in a nutshell, it leverages information provided to the world in an open way through the automatic identification system, AIS, that gives us insight as to where vessels that are operated in affiliation or direct involvement in deep sea mining, where, well, sort of all of the core sources of information that you might wish or want to have, the who, the what, the where, and the when of where they're operating in the spaces that Diva just shared. So an exciting benefit of sort of marrying the technology that's previously been built, providing insight and transparency for Global Fishing Watch, is that you can immediately start thinking about intersections, as Diva has shared, between overlap between fishing industry and fishing interests, again, a billion-dollar enterprise, and this emerging interest in seabed mining. But then there's a lot more opportunity that this transparency tool allows you to query questions that you can raise and hopefully answer with the tool. The one thing I'll sort of step out and say is that it's not the Deep Sea Mining Watch program and platform is not an advocacy product or project. It's a transparency and public service project. The general idea is that if we can make data accessible to all of the various stakeholders that have an interest and should be engaging in conversations about if and how seabed mining should or could begin, then decisions that we're making, which are very consequential in the moment, will come out more intelligently and more responsibly. Next slide, please. The stakeholders that can or should be involved in these conversations are much more diverse than just simply the fishing industry and those that are operating now commercially in the same spaces where mining is being proposed. So just give you a sense of who we hope might and expect might be using the deep sea mining platform and watch platform and why then it matters. There are, of course, all kinds of questions that can be probed by fishing industries, but you can imagine questions and users from, say, the Polynesian community, which might have an interest in space in these same zones where mining is being projected. You can imagine a cultural historical interest in some of the voyaging routes, which have great significance to those communities, and they might have an opinion of whether a mine ought to open in any of those zones. We can imagine a deep sea coral biologist who's tracking the fate of endangered or long-lived corals, being curious about intersections between mining activity and the distribution or habitat or range of these corals. We might imagine other industries beyond fishing, folks that are building undersea cables that link together data centers on the east and west of the Pacific have an interest in infrastructure and thus where seabed mining might occur. Coastal communities that are interested in where offloading of some of this product could take place if it moves to commercial status. There is concerns in science regarding the radioactivity of some of these materials. So there's, of course, interest in where precisely that's being offloaded. You could maybe, as a last example of how and who might be using some of this transparency insight, there are a host of different companies. For example, there's an automotive, BMW, Volvo, Rivian, others that have committed not to use materials that are mined from the oceans. The capacity to actually see some of these supply chains as they go live is unprecedented, and it allows them real power to be able to understand whether indeed some of their supply chains are connected to this material being proposed to be mined from the oceans. So just to sort of wrap up and again get into pass the baton to my colleague Paul and get into the matter of what you can see and how you can see some of these insights from deep sea mining. I just want to say that the goal again and why we hope this will matter is that data in effect is power, right? There are some very consequential decisions being made, as Diva alluded to, in the United States and the International Seabed Authority that are happening live right now. So it's a really exciting opportunity for us. We feel very grateful for the opportunity to make this data and this power available to everyone. So whether you're a member of any of those constituencies or stakeholders that I mentioned, you now have the capacity to see precisely where seabed mining is operating. And around those tables, we don't see members of those decision-making communities involved in these in these kinds of decisions about this industry, which indeed will shape what I think will become the 100-year future for our oceans. So it allows more folks to be at those tables, to have access to data, and thus have more power when they're sitting around at those decision-making forum. So, Paul, let me pause there and perhaps pass the baton to you to take us a bit deeper into the matter and technological details of the platform.
Great. Thank you, Doug. Next slide. We have a nice picture here. Okay, so I'm going to attempt a live demo here for you, but so Doug mentioned that the way we know what we know about these vessels is a system called AIS, Automatic Identification System. This is a radio system where vessels broadcast their locations over a radio signal to each other, so they can avoid collisions and otherwise know where other vessels are around them. These signals also go straight up, and satellites collect them overhead. And that is how we get most of this data, is satellites collecting those signals globally. We also have other ways to look at vessels with satellite radar and satellite optical, and you can see that in our platform. That's not very useful in the high seas. That's mostly coastal, so that's not involved here. It's really just all AIS. So now I'm going to share my screen. Hopefully, oh, someone has to release it to me. There we go. Okay, and now you should see my screen here. So I'll just give you the entry point. So when you come to the Deep Sea Mining Watch website, you'll see a nice big button right here, Explore the Map. That will take you into the tool I'm about to demo for you. This is the tool. So this lives inside Global Fishing Watch. You have access to all of the data and tools that we have in Global Fishing Watch. So I'm showing you here the Pacific Ocean in the summer of 2025 with all of the fishing activity visible. So this is a workspace. You can see up here we have, right, this is the Deep Sea Mining Watch workspace. This is a special presentation that we've prepared that lives inside the Global Fishing Watch platform. And one thing you're going to want to do is log in and or register. You can sign up right here. It's free. All you need is an email. And that way you'll be able to see all of the vessel detail information when you drill into things. So, so the way this works, you have a big map. You can go around the world. You can zoom out and zoom in the way you would expect the map to work. And you have this time bar here down at the bottom, which you can move around. You can also zoom in time, go in all the way down to look at a single day, or come out to look at years at a time. So right now we're looking at 3 months. We're down here near the Galapagos. And then you can see here, this is very nice. You can see the Galapagos protected area where there's no fishing, or almost no fishing, except for these local small vessels. So so that's the basic idea with the map. And then I'll just switch over here to another view. So now we're zoomed in here in the Western Pacific. We have the fishing activity, and this is one of the International Seabed Authority licensed areas here in the Western Pacific. This is Wake Atoll. I'll just come out here so you can see where we are. So there's Japan. So we're in here, and then I'll just show you some of the functionalities. So if we have the fishing effort on here, then you can go in and we can select a vessel by clicking on the map and find a vessel that's fishing there, or we can click on the ISA area and get a whoops, what I logged in. All right, let's just get that working. You can click on a report area and see the vessels that are active inside the report area. So this is all fishing vessels that were active inside this ISA mining licensing area. And then we can, I've already picked one, but then we can go look at a single vessel, and I'll turn off the overall activity. So that what we were looking at, the fishing activity, that was all of the fishing events over those 3 months for all vessels. And now we're looking at a single vessel over the same time period. and we can see where this vessel, this is, I think, a longliner. So we can see the track there. We can see when it was down here in this time slider. We can see when it was docked in Japan and when it came out to fish, and then the fishing events, and then as it came through. So then we can zoom down in here and see where it was fishing inside this mining area, and then we can click on the vessel name to get more information. So this tells us all the information we get from the AIS about the vessel, the name, the flag, the AIS identifier. If it has an IMO registry number, that's here, and a call sign. And then we can see where the activity. So let's pop over here. So now this is the Pacific Ocean. This is a set of ISA license areas that are organized by resource type. And then and we can see all the other ISA areas on the map, the same ones you saw in the earlier slides all around the world. And if we go down in here, and I'm going to show you these layers. So if I turn on we have ISA layers by contractor. So this is the ISA layers that have been licensed for exploration by individual contractors. And then I can go in here and I can filter this to say, just want the NORI polymetallic modules license. And confirm that. Oops. And then I should have, there we go, these areas. And then now we have the here we go, deep sea mining vessels. So we've selected 55 vessels that we know are involved in mining activity, and then we can see where they're active. And if you click on this, we'll give you a list, and so you can see this whole list. You can download this list. You can download the tracks, the individual tracks for the vessels if you want for your analysis. And oh yes, and you can see the whole world here of where they're active during these. This is now we're looking at all of 2022. So for the entire year of 2022, you can see where all those vessels were active. And we're going to go back down in here and look just at this area. And we have this vessel presence layer. So if we turn that on, we have built a model, a simple model, which identifies when these exploration vessels are actually engaged in the exploration activity. And so we have this little kind of heat map here. And you can see inside this particular area, we have some activity. And you could click on it, and we will tell you on the exact location you clicked what vessel that is. I think, there we go. That is the Island Pride, a seismic survey vessel. You can also do a report here that should give you those. Oh, shoot. So I logged out so I could demo you the login, and now I have to log in everywhere. We should be able to see the vessels that were active in that area and when they were active. So October 2022 was the peak of the activity level. And then we should see the vessels. Two vessels, the Island Pride, Norwegian flagged, and the Hidden Gem, Malta flagged. And then we can go in, and if we clicked on those vessels, we would activate them here, but I've already got them, so I'll just turn them on. So let's go look at the Hidden Gem. So the Hidden Gem was out here, and we can see, I'm going to turn off that overlay. So now we can see the voyage, the Hidden Gem coming out of the port in Mexico. So it was in, oh, that was when it was in Rotterdam. When was it? Oh yeah, here we go. Here's the port. So we have we actually have the whole voyage from Rotterdam all the way around. And then if I tighten this up to look at, oh, I want to look at September, right? So let's just narrow this time. There we go. So now it's in port in Mexico. And we can see it comes out to the mining area to explore, and spends a month and a half there, and then back to Mexico. Now we're going to zoom way, way in and see this little tiny area where all of this activity happened over the course of October. I can show you with a little ruler here that it's about looks like 3.5 kilometers across that area where they were working. Down in the lower right, I don't know how well you can see it, but you can see the latitude and longitude if you want to know exactly where that was. And and then in the track view, we can show down here. So you can see the speed of the vessel. So you can see that when it was on the way in and out, it's going fast. And then as it's active, it's very slow. It's less than 1 knot, 1 nautical mile per hour for the entire time it's there. So it's moving very slowly back and forth, and then it moves quickly on the way back. You can also see the depth that it's operating at. So you can see as it comes out of port, the depth drops down to 4,200, 4,300 meters. And then the entire activity here over this small area is all at a depth of about 4,200 meters. So then once you've found something that you think is interesting, you can go up here and you can share a link, and it will copy to your clipboard a link that if you give it to somebody else, they will come into this map with this exact view. So it makes it easy to share. You can also save up here and save this workspace of this current view in your profile in the Global Fishing Watch platform. So when you come back and log in, you'll be able to get to that workspace and retrieve it. And I think that's everything that I wanted to show you. So maybe I'll switch back now to the slide deck. If I can get back to my Zoom and not share. Oh, there we go. Sorry about that. There we go. And I'll hand it back, I think,
To
to
me.
you, Doug? To Diva.
Yes. So if we could get the slides back up, please, and thanks very much, Paul. So Paul has run us through a lot of the functionality of the system, and so I just wanted to, Doug and I are going to chat through 2 case studies specifically about deep sea bed mining. I'm going to handle the first one, which is about an expedition that the metals company ran that Paul has already alluded to, where the Hidden Gem vessel went out to the NORI-D license area and conducted a pilot test, essentially. So if we could move to the next slide, please. So as mentioned, the metals company, this is the company that is essentially, if we could move to the next slide again, please. The metals company is the company that is accelerating the deep seabed mining conversation the most. In particular, they've partnered with the US government recently. And really they have been the main entity that has been pushing a lot of this, this industry forward. And so they have a wholly owned subsidiary called Nauru Ocean Resources Incorporated, or NORI, which essentially contracted the Hidden Gem vessel that Paul showed you a little while ago to carry out tests of a polymetallic nodule collector system in the Clarion-Clipperton zone in 2022. And so here in this image, you can see the vessel moving out of Manzanillo, Mexico, and heading out to NORI-D, as Paul showed us earlier. And if we move to the next slide, we can then see that the vessel arrives on site. And I should say that this test was the only test conducted so far that included both a seabed collector as well as a riser pipe system. So it was able to essentially, for the first time, actually collect nodules and bring them to the surface. And apparently, this test covered a significant portion of sea floor and collected as much as 3,000 tons of nodules. And so if we move to the next slide, please, then we can see here the test itself. And so we can see that track has moved from the vessel steaming out to site to now showing the collector test which took place over an area of about 150 square kilometers, about the size of Washington, D.C., if you will. And the collector apparently drove 80 kilometers during this time and collected 4,500 tons of nodules, of which 3,000 were brought to the surface production vessel, the Hidden Gem. And so what we can actually see here is the vessel is relatively stationary during this time, or moving very slowly, about 0.5 knots, which is the speed that most vessels use when they are either conducting mapping or conducting activities that require over-the-side equipment. We can also see that there's almost been a mosaic type activity that's been run here. The track looks like the seafloor has been mowed in a way. And so what that is showing is that the ship would be mirroring the collector vehicle moving along the seafloor, which would have been mowing the lawn essentially. And if we could move to the next slide, please. I should also add as an aside that it is during this test by the metals company in Nori that there was an environmental incident. So if we move to the next slide, there was a video leaked from on board. Sorry, the previous slide. There was a video leaked from on board the Hidden Gem that showed deep sea mining waste being discharged into the surface ocean. And as I said previously, that would have been water of a different temperature, chemistry, included sediment, included nodule fragments. And it's really unclear what the environmental ramifications of this spill were, but it really highlights how out of sight and how out of mind this industry has the potential to be. And if we move to the next slide, so the Hidden Gem then went back, as Paul showed, to the eastern coast of Mexico and the US, and essentially then it then steamed back out to sea a year later and showed the Hidden Gem going to dock in Hawaii with the nodules on board. Instead of being able to dock in Hawaii, that they were met with strong indigenous opposition. This is something that Doug has already alluded to. For instance, activist communities or Polynesian communities wanting to engage with this tool. But essentially, the Hidden Gem was met with this strong indigenous opposition in Honolulu and Hawaii. And that led to, from this community-led protest, led to the Hidden Gem diverting its route and not actually coming into port in Honolulu. It then, if we move to the next slide, steamed actually on to South Korea. And that's potentially hinting at the fact that seabed minerals may have ultimately been landed there. And this may be in relation to the fact that, as was released recently, there's been an $85 million deal between Korea Zinc and the metals company for seabed minerals processing, the processing of these nodules and, well, commercial nodules gathered via commercial mining. And this really highlights that the utility of the Deep Sea Mining Watch platform, it's not just about increasing transparency while at sea, but there's also the potential to really increase transparency across the entire supply chain. So I'm going to pass on to Doug now, who's going to talk you through the second case study.
Thank you, Diva. So I'll just go quickly through another case study. I mean, really, the number of case studies are as many as you have questions. And so we just want to give you a little bit of a search image of the kind of inquiries you can pose. And I want to reserve time so that we can get to actually tackling your questions directly about how to use the platform. So the second case study, we're going to move further west. We can jump to the next slide. Further west across the Pacific, and I'm gonna just show you a portrait of activity. You just gave a quick sketch of this, Paul, as you were searching and fishing activity. We were in the same space a moment ago, but we're now near Japan. So Japan is in the upper left hand part of the screen, the actual main islands, although the circle here in the center of our screen is also part of the Japanese EEZ, exclusive economic zone. This is a Japanese vessel that is actually, instead of mining or doing exploration in the high seas, which is the case study that Diva just shared, this is an instance of exploration and extraction within a country's EEZ, within Japan's own national waters. So in this, we're zooming back to July in 2020. So this is a expedition that was run by the Japan Organization for Metals and Energy Security, or JOGMEC. So they took they sent the vessel, the Hakure, down to this section of the Japanese EEZ, and they're actually looking at a different resource. So Diva shared a moment ago exploration and collection of resource in the Clarion-Clipperton Gem, which is focused on polymetallic nodules. This is actually a collection that occurred, if we go to the next slide, on top of a seamount or an undersea mountain. So it's the Takayo Daigo seamount, again, within the Japanese EEZ. And a seamount is just effectively a mountain that comes up towards the surface of the ocean, but it doesn't break the surface, becoming an island. These kinds of seamounts, in addition to having really interesting geology and marine geochemistry, they actually also are biologically important, ecologically important features. They end up being sort of signposts for migration routes, and they're oases of biodiversity on our oceans. So we have the Hakurei comes down in July 2020 and does extraction of this other mineral resource. This is actually a cobalt and nickel rich crust that forms on the top of these seamounts. In this instance, in this period of activity that you can see here, they collected 749 kilograms of material and then brought it back to the Japanese islands. And if we go to our next image, that just again is to give you a little bit of a portrait of the kind of inquiries. In that instance, we're looking at a different mineral and a different space inside a national EEZ. When I think we've got a good sense of potential overlap between fishing and seabed mining, but perhaps just to add in one additional example of how you can think of those intersections. In the previous image, when we were looking at the Japanese extraction within their EZ, you saw all of the other lights on, all the activity from commercial fishing that's occurring in those same spaces. But now I've moved back over to leave you just one final taster of ways that we can actually query intersections between fishing, $1 billion tuna fishing industry, and seabed mining. We're in the CCZ and the Clarion Clipper Zone in the Central Pacific, where Diva just drew up her case study, but we're in the northern part of the CCZ. And we're actually looking at a claim area, exploration claim area issued to China. And then you see fishing activity here in green. You can drill down, as Paul showed you before in his live demo, to see what is that vessel. And in fact, in this instance, that vessel is the Serenity. It's a U.S. flag vessel that's operating fishing for tuna out of Honolulu, out of the United States. So we could go on and on and on, kind of digging into different case studies, but the point is not for us, but for you and colleagues, for the world to do this kind of exploration and to surface and answer their own questions. So I think it's probably prudent to pause here, perhaps seeding a few of the kinds of questions you can form, but I'd love to pass the mic back over to Sarah to field some of your questions to make sure that we leave everyone empowered to do their own exploration from here.
Thanks so much, Doug and Diva and Paul. So we've got a little over 15 minutes to field some questions, and thank you. We've received a number of those in the Q&A box. By all means, keep them coming. Or if you have a preference to give voice to your question, you can also use the hands up feature and we can unmute you to also be able to speak. I'm just going to pass to Paul initially. There's a couple of follow-up questions about what's possible in terms of both what can you download, whether that's GeoJSON or shapefiles, what could you upload? Maybe you could speak a bit to what users can also upload. And then indeed, what information do we capture about a given vessel? How much do we know about it? What information is available? And particularly, do we know anything around the companies behind these vessels?
Thanks, Sarah. Yeah, so for spatial data, GeoJSON or shapefiles, you can upload any any polygons that you want. You can actually do analysis like you saw me do on the ones we provide. You can do the same analysis if you wanted to create a custom area and say how much fishing happened here, how much of the mining exploration activity happened here. You can do that. We don't have a way to download the ones that we packaged, but we're certainly happy to make them available. So I was just chatting with the folks here. We should just put those on the website and let you download them. Those are all derived from public sources, so they're available other places. But we've gone and collected them all in one place. So you can also draw a polygon right on the map. I didn't demo that, but you can just like click, draw a little area around something you're interested in, and then report on that. So then what information you have about the vessels. So we, for these vessels, they're registered with the IMO, they're big vessels, and so they all have an IMO number. And from that IMO number, you can learn a lot. We have some of that, vessel name and registration. For fishing vessels, we have where they're licensed to fish, and with licensing bodies. With these exploration vessels, we have the IMO information, which will tell you the owner. That doesn't tell you who they're working for, though. So the affiliation, what company they're actually doing the exploration for, that's not going to be public necessarily. So that definitely requires some research and investigation. We've identified these 55 that we put there that we know are involved in that. I should also point out that just because a seismic survey vessel is engaging in activity doesn't mean it's looking for polymetallic nodules. You need to look at where it's active. So if it's out in the middle of one of these ISA areas, that's what it's doing. If it's off the coast of Brazil where they drill for oil, it's maybe looking, they may be prospecting for oil. So there's a little bit of context that's important when you consider these activities.
Thanks, Paul. And I'll come back to you with a few more specific platform questions. But I just want to pass to Diva now, because there's been a question that's come in around what, if any, rules exist to regulate seabed exploration or collection within countries' national waters within their EEZs? And does each country make its own rules, or are there any international agreements concerning seabed mining inside EEZs?
I feel like the person who's asked this question has answered part of it themselves. So within national jurisdictions or in exclusive economic zones, it is up to each country to make the rules that will govern deep seabed mining or any mineral related activities. And so there are some countries that have been for many years now have been working on these rules, regulations, and procedures, and are quite far advanced in that respect. However, there are others that have not even begun to consider this, even though they may have a potential industry gathering pace there. And so with regard to the second part of the question about whether there are international agreements concerning seabed mining inside the EEZs, it's my understanding there are not. However, the regulations, the mining code, which is all of the regulations, rules, and procedures that the International Seabed Authority is in the process of developing for exploitation, that those should set a minimum standard for application within national jurisdictions. But of course, with all of this, there is without effective implementation of these potential rules, regulations, and procedures, all of these will just be words on paper, essentially. So it's really the implementation that is the critical question here. And we've already seen how, again, how remote a lot of this is, how out of sight it is, and how big the risks are.
Thanks, Diva. I'm going to pass to Doug now. So, not surprisingly, Global Fishing Watch, it's in the name. We track fishing vessels. That's where we have rich data, near real time, tracking the industrial fishing fleet. And some of the visualizations Paul presented clearly showed that a lot of these license areas are where fishing grounds are. So the question is, has the fishing industry raised concerns about seabed mining exploration and ultimately potentially exploitation interfering with fishing operations?
Thank you, Sarah. I want to take that head on, but I also want to note that even though there's that marriage of the historical expertise of Global Fishing Watch and visualizing fishing activity, there are all kinds of other stakeholders and points of intersection that can be explored and questions that can and hopefully will be asked by other stakeholders beyond fishing. But to the question, I would say that there is still fairly nascent engagement from the fishing industry when it comes to weighing in on their opinions and their views about if and how seabed mining should begin in some of the areas that have been core for fishing for them for decades, and then importantly, what areas will be core and vital strategic importance going forward. So fish are moving on our ocean as our ocean changes as a result of climate change. A study that Diva led that was released some time ago projected that, in fact, the overlap between fishing and mining, as you can see today in the tool, actually only intensify based on the forecasted footprint of where tuna, which is the principal resource from economic standpoint, that the overlap is only forecasted to increase. So despite that overlap, and the potential conflict, and Diva, indeed, I do want you to weigh in. Despite the overlap and the potential conflict between these two industries, the actual engagement from the fishing industry, I would say, has been relatively nascent. So, for example, the undersea cable industry has been present at the International Seabed Authority, engaging in conversations about their industry's interest for almost a decade. But only recently have some of the industrial fishing, some of the fishing, the groups that actually represent and oversee fishing activity begun to weigh in these conversations. So, for example, tuna fishing in the Pacific is largely overseen by two regional fisheries management organizations, the WCPFC and the IATTC. Both have recently reached out and connected with the ISA about interest to begin joining those meetings. The WCPFC is formally petitioned to have observer status to be able to engage in those conversations. So there are some first steps. Of course, that's more at the international level, and this intersection questions about this intersection in international waters. There is, I would say, well, I might anticipate, or there's more opportunity for engagement at the national level. So whether the U.S., whether the Japanese fisheries are engaging with their own governments about both questions about intersections and overlap between fishing and mining in the high seas, but also within national waters. And then, of course, there's also the opportunity, which is the kind of equality for engagement that we hope transparency engenders. But as we saw, you can drill down to a specific fishing vessel. And so for individuals, for captains, for operators, they can see how their activity in the middle of the ocean, you don't know if you're sitting on top of a mining claim area or an area that is proposed to about be mined, but now you do through this platform. So they can engage with their industry representatives or engage directly in these conversations. Diva, let me pass to you to add.
Yeah, I just wanted to very quickly add a little bit more thought there in that while it is nascent, there has been some engagement from seafood industry groups themselves. In fact, in 2023, there was in the first of its kind, a statement, a letter that was released from seafood industry groups that really advocated for a pause on deep seabed mining development until the socioeconomic and environmental impacts could be more thoroughly analyzed, especially on the fishing industry. And I mean, that included signatories from the Sustainable Seafood Coalition. It also included the Global Tuna Alliance signing on, which accounts for 32% of the global tuna trade. So really, I think there is there is accelerating concern and it especially is permeating through the industry itself.
Look, Ed, just to add one, sorry, sorry. Well, if this was a mine that was opening in your backyard on land, you would see it, you would be issued, or you would demand a map, and you would have that kind of access to data. The oceans, the backyards that we looked at here are indeed all of our backyards, as Diva said, our backyards. They're common heritage resource that are also the backyards of future generations. But the idea with Deep Sea Mining Watch is to provide the opportunity, because those backyards are more out of sight, out of mind for others, including the fishing industry, to actually have that transparency that's been absent. So we might see more engagement around this data as the data becomes the facilitator and the power for that kind of future engagement from the fishing industry and others.
Thank you, Doug and Diva. Before I come back to Paul, we've got a bunch of platform questions I'll bundle up for Paul, but I believe we have Rachel Ramirez with CNN who has her hand up who'd like to ask a question. Rachel, are you there, and can we unmute you?
Hi, can you hear me?
We can.
Okay, perfect. I am actually no longer with CNN, but I am
My apologies.
working on deep sea mining in my own capacity. I recently got a grant to report on this, and I've been researching for months now. So thank you so much for this, and I'm super excited to dive into this platform. And yeah, I have a couple of questions. I'm really interested in the recent US-Japan deal, and I'm curious how you all think we can use this map to sort of tell a story of the geopolitics of it all. Like, is there a way to maybe do some sort of side-by-side comparison between, say, China and the US? And yeah, I'm just interested in like ways to tell the story of the geopolitics. And also just a different part of that is Can we also see the plumes? Can we track the plumes in this map? See the discharge? I know there was also a report on seeing the discharge from satellite images, but yeah, I'm really interested in that too. Thank you.
Great question. So we'll take the geopolitics first, and then I'll pass to Paul on the plume. Doug, would you like to take that one on?
Well, Rachel, it's a great question, but you're asking an ocean scientist to weigh in on geopolitics. So I'm going to largely say that the platform is about trying to give everyone, including reporters, a few of those raw resources to be able to probe these kinds of questions on your end. You don't really want me to be doing an analysis of what actually what you hear nations saying or posturing, and then what that reveals in terms of activity on the oceans. What I think we're hoping with the platform is allow you to actually see in a way that wasn't possible a few months ago what actually is transpiring on the oceans, and then to link that to what's happening in dialogues between nations. So I hope I'm not, well, I am sidestepping your question, but it's simply out of a point of responsibility that it would be much more responsible for you and colleagues here that are trying to interpret, what is actually happening, what is being said. Hopefully, connecting the dots, we actually are adding some facts to the opportunity to interpret some of those geopolitics. I'm sorry, it would only be irresponsible for me to postulate further than that. We want to talk about corals or sound pollution or noise pollution. Glad to go there.
Thanks, Doug. And then Paul, maybe can you speak to what we can see around the vessels? Can we see plumes? Can we see wider activity or impact?
Yeah, I wish we could see the plumes. We do see plumes from bottom disturbing activity, particularly bottom trawling, fishing trawling, in coastal areas in shallow waters, routinely with satellite imagery. But this stuff, well, first of all, there are no plumes, right? Because this exploration is not producing massive plumes because they're not actually mining. Um, but even if there are plumes, it's very unlikely we'll be able to see them from satellite because they will be at hundreds of meters below the surface. And they will spread out from there to thousands of meters below the surface, slowly raining back down. So we don't anticipate being able to see them. This is one of the problems with making this more transparent, is that you really can't see the actual activity unless you have your own ROV down there on the bottom. Doug, were you going to add something?
Well, the only thing I'd add, Paul, is that just like any technologically complex industrial activity in the oceans, there can be accidents. We saw Diva shared a portrait of this environmental incident on top of the footprint of data that you could see in Deep Sea Mining Watch. So there is the opportunity to try to do, if there are future accidents where plumes are released accidentally or or purposely or for whatever the motivation, if there are plumes that are released at the surface of the ocean, then those that in some future iteration, there's a lot of growth potential on the platform. In some future iteration, there's the opportunity to visualize those, to take images of those from remote sensing, and then to layer those in a spatially explicit way on top of the tracks.
Yeah, that's a good point. We
Let's
do
hope
that
there's
routinely with oil slicks, and associate those with the vessels that are producing them. So if there are stuff visible on the surface, we will see it and we'll be able to make that available.
So I know we've only just got a minute or two left, and I'm going to bundle up a few rapid fire platform questions to you, Paul. There's questions around how up to date's the data? Is there timestamps? How current's the data? How do we understand the integrity of the data? Issues around disabling AIS signals or spoofing, intentional manipulation. Can we see it? Do we know about it? And then is it possible to track exploration activity over time, to create a data set, for example, by hour, per month, by flag, by ISA area? So maybe you could speak to a few of those, please.
Yeah, sure. So with the AIS abuse, that happens. We have a lot of mechanisms for detecting it. They can turn the AIS off. They can spoof their identity, right? Broadcast a false identity. They can actually manipulate the GPS to broadcast false locations. All these things happen routinely. Generally not with these vessels, though. These exploration vessels, are monitored pretty closely. They're all, registered with IMO. They're all mandated to broadcast AIS continuously while they're while they're moving. So we don't see that kind of behavior with these vessels. We do, if there are gaps in the AIS broadcast, you will be able to see it in the platform. We have in the vessel profile, there's a little place where you can see events associated with the vessel, and you'll see that it has gaps. And we also have the AIS continuous rating, so we give it a rating of how good a job it does at being continuously trackable. These vessels, though, should be doing pretty well. I'm sorry, what was the
Around the currency of it, the timestamp, how up to date is the data?
Oh, yes, right. So we update this platform daily, and the data is 72 hours old, the most recent data, and it goes back 10 years. So, and you can do a time series analysis across that entire time frame. Though I don't know, obviously there's not any polymetallic nodule mine exploration activity 10 years ago, but you go back over the years, you can actually get the data out at the day granularity or the month or the year granularity, and you can do reporting based on the areas, right? Polygons that you put in there. You can get a time series. I showed you a graph of a time series of the fishing activity over inside a polygon. So you can produce that for yourself, for your own polygons. You can actually do it for a select set of vessels. And you can there's a filter for the vessels by vessel flag. And you can use that to do that's of course the flag state of the where the AIS is registered. So that's not necessarily where the owner is, but because there are flags of convenience like Belize and Panama and Liberia that'll be the flag state, but the actual owner will be somewhere else. So you have to again think about the context. But all of that is you can do with the data from the platform.
Thanks, Paul. I know we've run over and I appreciate there's more questions. So I will just thank you all for attending the media briefing. We've just flashed up here the QR code that gets you through to the platform we've just provided a preview of. Just a reminder that this is under embargo again till this Thursday at 9 a.m. US Eastern Time. And do look out for the media kit and the embargoed press release that'll be coming through to you from Andrew, who's set this whole briefing up and has been in touch with many of you. Andrew can answer any specific questions. We're also delighted to be able to offer one-to-one further deep dives into the platform or to understand any particular case studies. As Doug mentioned, there is a deep well of potential areas to explore, and we would be eager to collaborate with you on the potential to investigate some of those. So please do visit our website, globalfishingwatch.org, and the Benioff Ocean Science Laboratory for more information about our work. And I think we'll leave it there. Thank you very much for your time. Looking forward to collaborating.